How's everyone doing this fine morning? It's afternoon now, even better. Alrighty, let's talk some servo motors. Now, today we're going to go through a couple of different programs for servos. This is all part of 1.08, which is our skilled level circuits for our introductory class, but it can be used as a tutorial for anything servo related. Now, just so you guys know, I'm assuming if you're watching this that you've already watched the wonderful SparkFun project showcase here, where they talk a little bit about some of the servos. They talk about standard servos, micro servos, the difference between a positional and a continuous rotation. I may touch on those today too. We're going to do this in Tinkercad. We are going to do this in real life. As you can see, I've got a nice little servo setup going on here with my Arduino. Not fully cooked up yet, but that is what it is for right now. And we are going to go ahead and make that happen. All right, so we're going to talk about servo sweep. We're going to talk about servo knob. But before we do that, and I've opened these up, by the way, sweep and knob, we're going to start with sweep, and I'm actually going to change sweep around so that we can do something really fun with it. So if we go down, we can get our sweep code down here if we want to. We can also get it through our IDE, and I am just going to go, and it's under File, Examples, Servo, and there's knob and sweep right there. Let's go through this code. Let's talk our way through it. And again, I'm going to use the IDE because it is better for you to read this stuff in a video. And another thing I'm going to point out is if you go to File, Preferences, you can actually check off Display Line Numbers right here. And that's something I'm going to use here to talk about some things on a few lines. Now, what I'm going to do is we're going to go through this line by line as we usually do. So let's start. Line number 10, we have the command include servo.h. Now what this is doing is it's bringing in a servo library. Now a library is like a peripheral piece of code. It's something that's not included with the base Arduino that you wouldn't use all the time. Something like a servo or a serial, like an I2C connection, things like that. In this case, servos are not included in the base programming of the Arduino. We're going to bring them in. We're going to bring in a bunch of codes that we're going to use here. Now, the very next thing, this is actually part of object-oriented programming, and we're not going to go too deep into that, just you need to understand that it works in this case, that's all. We're going to actually go into the servo library, and we are going to name a servo. So we're going to actually create a servo, and we're going to call it my servo. Now, if you end up having a circuit that has more than one servo in it, which you may end up having multiple lines of this code, and you might be creating objects that are my servo. You might have objects you create that are servo 1, servo 2, servo 3, those sort of things. Now, we're going to refer to this my servo as our one servo that's in this circuit for right now. Okay, we're going to create a new integer variable called position, and we're going to make it equal to 0. Now here's the cool part. We're actually going to attach our servo. So we're going to use my servo.attach. We're going to attach it to pin number 9 right here. So this is important. When we hook up our circuit, our servo is going to be attached to pin number 9. Now, let's jump down to loop, and I'm going to do something that's a little bit weird on this one, in that I'm actually going to comment out that is /star, not //. All right, I'm actually going to comment out, I've already got the one at the bottom here, all of the code from the loop on this one, and I'm just going to move them down a little bit. The reason I'm going to do that is I really want to just show you how one command out of all this works, and that's my servo.write. Whoops, went the wrong way there. So let's talk our way through this. I'm just going to go up to Tools and auto format this so everything lines up where it's supposed to. Okay, so my servo write in our code was going to use the variable position. All right, we created that earlier. But I'm just going to tell you how my servo write works. It actually wants to get an angle between 0 and 180 degrees. So I'm going to show you the difference between those. We're going to start with a my servo write 0. Okay, and what we're going to do is we're going to put a my servo write 180 degrees. And I'm just going to put a delay in between them. And I'm going to put about a 1.5 second delay in between each of them, just like we would see with Blink, where we turn the light on and off. We're going to be able to see this servo work. I'm going to go up to Tools, and I'm going to click a button called Auto Format here, and it's going to line everything up for me. I like that button. It keeps things nice and clean. All right, so right now, the servo is going to go to 0 degrees. Then it's going to delay for 1.5 seconds while it moves. It should be traveling while it does this. Then we're going to send it to 180 degrees. Then we're going to make it wait a second till it goes back, and then we're going to go back to 0. Back and forth, back and forth. That's all this does. Okay, let's try this code out, and let's go over to Tinkercad to test it first. All right, so hop over here. Here is our Tinkercad, and I'm going to show you what I've hooked up. Okay, I've got my usual breadboard set up. Hooked up my power rails to ground and 5 volts. I've jumped them over to the other side of the board. Now your servo, whoop, don't drag the servo, I want to drag the screen. There we go, drag the screen. It has 3 ports on it, 3 wires, black, red, and orange. Black is your ground wire, negative. Red is your VCC or your power, okay? And orange is going to be your signal. That's what we're going to send an actual PWM signal to, just like we did with those analog right LEDs and a few lessons ago. So the signal is going to tell it which angle it wants to actually go to. Very easy. Okay, I'm just going to paste this code in here, and we're going to test out how it works. Now what I should see is I should see a servo that starts at 0, waits a second and a half, and then turns itself over to 180, then goes back. Now it looks like it's stopping at the end here, so I think this is the full range of motion of my servo, which is not quite 180 degrees. That's pretty common for micro servos. Each servo's range of motion is slightly different. Some of them work just slightly differently than other ones, and you can usually check the data sheet to see what they're intended to do. These micro servos are really small, they're relatively inexpensive, and they work really well for learning servos, but not for moving a whole heck of a lot. They actually tend to be a little bit jerky. That being said, let's check the real-world version of this. I'm just going to stop this code, and I'm going to hop over to my servo sweep, and I am very quickly just going to hop over to Tools. Yeah, I got my Arduino hooked up, and I'm going to press the Upload button and jump over to the Arduino itself. You're going to see it upload. Oop, and I've unplugged my servo. So I'm very quickly just going to plug my servo in. Now that servo is hooked up exactly like the Tinkercad circuit. I've got a wire running into the positive power rail, a wire running to the negative power rail. That's red and black, or red and brown respectively. And my orange wire, this one right here, is running back to pin number 9. You can see that servo works exactly like it does in Tinkercad. Okay, it's going just short of 180 degrees one way and the other. Now, let's talk about the next piece of code here. I'm going to hop back to the IDE for Arduino here, and I'm just going to make these, I'm going to make the my servo and the delay just go away, and I'm going to uncomment the stuff that we had before. So let's talk about what this code is actually supposed to do here. Now, what we have here is actually 2 for loops, this one and this one. And each for loop, I'm going to skip over what's in the for right now. All the for loop does is it runs over and over again the same 2 lines of code. My servo.write position and delay 15. Now obviously this means that this for loop is going to change that position variable each time it runs. It kind of makes sense. So let's read this. For the first for loop, we start at a position of 0, and as long as the position is less than or equal to 180, which represents degrees in this case, okay, we are going to keep going. And each time we do that, we are going to take the position, and we're going to take position equals position plus 1. That's what this says. So it's going to take the previous position, let's say it's 5 degrees, the next time it runs it's going to be 6, the next time it runs it's going to be 7, and then 8, so on and so forth. So we're going to move this servo 1 degree at a time 180 times. That's what this code does. Now the second piece of code starts at 180. It says as long as the position variable is above 0 or equal to 0, we are going to keep going, and every time we are going to take the position equals the position minus 1. So we're just going to increment back down. That's all this is. Okay, I'm going to click upload on this code. I'm not even going to bother with this one with Tinkercad, but let's take a look at what this does to the servo. Okay, you can see the servo moving. Now you notice that was way slower than the previous one, and also that this servo doesn't quite make it all the way to both ends. Okay, that just has to do with the delays on this one. I'm just going to hop back here and I'm going to mess with this. I'm going to put a 25 millisecond delay on this. I'm going to edit my comments while I'm at it because that's always good form. Okay, let's click upload and see what happens. So all I've done now is I've just changed the delay. Now instead of delaying 15 milliseconds between each, it's going to move 25 milliseconds between each. And what happens is it moves a lot slower, but at the same time, it actually moves all the way through its range of motion, it looks like, okay? Because it's pausing more in between. Okay, remember, when we did the first thing, we just sent it a message, go to 0. And by the way, and I'm just going to hit the reset button on the Arduino here, watch this. When you reset your Arduino, if you use this code, it's going to reset the position back to 0. That's the very first thing it's going to do. So watch this. Press reset. First thing it does is sends it a 0 command, and it goes back to 0, okay? It's kind of like it's reset. All right, now let's talk about knob, because as you can see, I've got a potentiometer hooked up here, and we're going to hop over to the other one. Actually, I'm going to hop over to Tinkercad for a second here and show you the knob piece. Okay, so all I've done for the knob is I've taken a potentiometer, and I've actually hooked it up just like we did in our analog read. Okay, so it sets to A0. We're going to learn one new command when we do this. So let's hop over to the actual code for knob, and let's walk our way through. Okay, servo library included. Great, we made a servo called my servo. Awesome. We have the 2 new variables we haven't seen before. One is pot pin, okay, and I'm going to set my pot pin to A0. And we have an integer variable called value this time, which is the same as position for all intents and purposes. There are some naming conventions for variables, but in this case we're in a really small piece of code. So we attach our servo to pin 9, that looks normal, and then let's read what this code actually does. So we're going to take the value variable, and we're going to make it equal to an analog read of pot pin. Okay, so whatever's coming in off of that potentiometer is going to be what we actually do with this servo. That's the word I was looking for. Now remember that an analog read is going to get you a number between 0 and 1023. And we actually want to export to the servo a number between 0 and 180, which is where this next command comes in. And this is called a map command. Now, a map command is relatively simple. I'm going to use the analogy. I use this one every time because students tend to get it. Your teacher hands you back a quiz that is out of 18. You would now have a mark. In this case, the mark is the value. Let's say you got 9 out of 18. Okay, 9 out of 18. Okay, the quiz itself was a range between 0 and 18. That was your actual range you could work with. Okay, at the same time, you want to know your percentage value. You want to know what it was out of 100. So that's a range of 0 to 100. Now, the map value is simply a piece of math that could help you calculate that. And you usually do this on your calculator or sometimes in your head. And you say, okay, if I got 9 out of 18, that is the same as 50 out of 100. That's a 50%, right? The map value is going to do the exact same thing. So it gets a value here. It gets a value here between 0 and 1023, and it turns it into an equivalent value between 0 and 180, because we want to bring in the information between 0 and 1023, and we want to send out the information between 0 and 180. So we literally just let this map value make that conversion. So value equals a converted value that comes in from 0 to 123 and comes out between 0 and 180. Then we take this my servo and we write whatever that value is. Super easy. We delay for 15 seconds and off we go. Okay? I'm going to actually add one more piece of code in here just for fun, just so we can see it. Okay? I'm going to add a serial monitor on here. Okay? Serial.print new line, and I'm just going to print out what the value is. Okay? I want to see what the actual angle that it's sending to the servo is. And in order to do that, I also have to go up into my setup and do a serial.begin 9600. Okay, there we go. I'm going to go to Tools, and I'm going to auto-format this so everything lines up really nicely. I'm going to grab this code. I'm going to go test this in Tinkercad first, I think. Okay, so let's go up here. Let's paste it in. Let's start our simulation. All right, we're initializing. Okay, so our servo moved right off the bat, and that kind of makes sense, because right now the serial monitor says it's looking at trying to get to 100 degrees. But as you see, as I move this potentiometer, I also move this servo. And this is kind of the core idea behind a lot of tools. If you ever think of like an excavator, for example, something where you're using it to dig dirt. This is similar to what you would be doing with that, often with hydraulics and much larger equipment, but the same idea, right? In many cases, the sensor is coming into a computer of some sort. That computer is going out to some sort of actuator, which is the term we would use for this movement device. Now I'm just going to throw this code just for fun into the actual IDE, and I'm going to demo this for real. That's my knob version. Yeah, that's my knob version. Let's do this. Okay, and I'm going to click Upload. I'm set to the Arduino. Good. Okay, and let's check this over to what we've got over here. I'm going to try to keep my hand out of the shot as best I can while we have this actually move. Okay, so it reset itself to wherever the knob was. I'm going to slide over here. I'm just going to spin this. Oh, what's going on here? There. Oh, I have a wire missing. That's unfortunate. This is part of that troubleshooting process, making sure you have a nice, easy to work with workspace. I'm just going to go spike a wire very quickly into the other side of the potentiometer. That is negative, that is positive. Okay, and as you can see, the Arduino actually started moving there. So let's take this and let's spin the potentiometer. And as I spin the potentiometer, my Arduino spins with it. Okay, I can control things. I have control. We have created an electronic control system, guys. Now, I hope you learned something from how those pieces of code work. I hope some of this was a review for a lot of people, and I hope you have some fun moving your servos around and playing with them with code and with sensors. Enjoy.